And yet another simple trig identity. And we have sin x times tan x minus secant of x. And I'm assuming that you are aware that tangent of x can be rewritten as sin x over cos x, and that secant of x can be rewritten as 1 over cos of x. And why do we do that? Well, you know, when I'm dealing with trig identities, I prefer to have everything in terms of sine and cosine only. So that's why. Okay, so we have sin x times sin x over cos x. So I can multiply the sin x and the sin x. So I get sine squared x up top over cos x. And I have 1 over, or minus 1 over cos x. There you go. Now, my preference will be to combine these two fractions. Note that we already have a common denominator of cos x for both of them here. So I will just combine them right away. That wasn't very straight, was it? There we go. Cos x. So now I'll combine them. So I get sine squared x minus 1 over cos x. And is there anything else we can do here? Yes, there is. And you must remember the Pythagorean identity. Sine squared x plus cos squared x is equal to 1. So let's rearrange this a little bit. We know that this is a fact. We're certain that that is true. So we have sine squared x minus 1 here. Okay. So, well, I'm going to throw the 1 over to the left-hand side of the equation and the cos squared x to the other. So I get sine squared x minus 1 equals negative cos squared x. And I almost ran out of room here. So this is exactly what we have there. And it's equivalent to negative cos squared x. And we have it over cos of x. Great. What can we do now? We can just cancel out the square here with a cos, and we end up with negative cos x. And why is that? Well, because cos squared x is just cos x times cos x, right? So that's what we really had. So they can cancel out, and we end up with just negative cos of x. That's it.